Ladies and gentlemen, good morning, good afternoon, and good night for all of you that are in different parts and areas of the world. And welcome to the third and final day of Pediatrics 2040. I don't know if you're excited as I am, because these first 2 days of the conference were so good, and I'm missing all of you. I must say that next time, absolutely, we hope that this conference will happen in person. I'm Alberto Tozzi. I'm from the Bambino Gesù Children's Hospital in Rome, Italy, and I'm honored to present the speakers of this last day. Before that, let me thank all the sponsors that made this conference happen. Not only they were active in supporting the conference, you can visit their virtual booths down in this webpage, just clicking maybe during the break and looking at their products. Don't miss that, because you will find out very interesting things. Let me thank you also, all the members and all the partners of iSpy. This is a community which is very alive and very passionate. That if you're not part of iSpy yet, please consider the possibility to be part of the game, because this is really, really something big. And I hope that you will join us as soon as possible. A couple of things also on the activities of this community. iSpy has a LinkedIn account that you can follow just to understand what's going on and to look at the activities that may be of your interest. You can also be in touch with iSpy members, which is also something that you understand after these 2 days of the conference that might be extremely appealing for the future. You can, and I hope you will do so, post comments during the sessions in the chat window. You can also have a real-time translation in your language if you need, but please feel free to post comments and also ask questions that might be extremely important also for the panelists, and also to make a more active interaction with you. So don't be shy. That's my recommendation. Today we will have a very exciting number of sessions, different ones. The first part will be mostly about AI and data sharing. This is something that is very ahead of time, and I think it will be also bridging some of the gaps that we have in our discussions with our colleagues in our hospitals. So this will be the first part of the day, while in the second part of the day, we will be dealing with other very important topics like mental health, how to translate clinical guidelines into something more efficient. And let me tell you that this is one of my favorite topics, being an epidemiologist, and also a COVID session in which we will be discussing something about the things happening. Now it's time to introduce our first keynote speaker. I'm pleased to introduce Tim Chow. Well, I met Tim several years ago in California, and when I first met him, my thought was he was too much ahead of time, and the things he was telling us were really, really the future of our activities in pediatrics. But I followed him, and over the years, he made a lot of steps and advanced a lot of the things he was simply telling us, and made some of them real. So I'm very honored to introduce and pass the mic to Tim Chow for his keynote lecture on AI and naturally and kids. Tim, the floor is yours.
Well, thank you very much, Alberto. A great introduction. As Alberto said, what I want to talk about today is really things that, by the way, Anthony has talked about for quite some time, which is artificial intelligence and what could that do for kids. I think I'm going to talk about three big challenges, of which one of them I think we're way down the path of having solved, and leave you with two things to think about how do we get those done. So I'm going to start by saying, in the beginning, and maybe this is in the beginning of I Spy, in the beginning of Pediatrics 2040, certainly in the beginning of what I have started to work on is Anthony. So special shout out to the fact that sometimes the student inspires the teacher. So I met Anthony because I teach this cloud computing class at Stanford. And one day he comes into that class and that has changed everything. So his early invitations to Pediatrics 2040, and some of you saw early PowerPoint presentations about an idea we talked about as a pediatric cloud. The evolution of that is what I want to share with you today. And just want to say again, thanks, Anthony, for inspiring us all. I'm going to start with talking about why does this matter to any of us? Why is AI, which is very cool technology, why does it matter? The second thing I want to talk about is technology. We have developed something we call an edge cloud. I'll take you through that in a very simple way. And in essence, it is an ability to do safe, precise data sharing on a global basis. I'm going to take you through 5 different applications of it, just so you can kind of get an idea of the power of this type of infrastructure. And then I'm going to leave you with a couple calls to action that I hope you take me up on. So why does this matter, right? I think at the end of the day, it matters because in the world we're heading into, we need to figure out how we deliver equitable, global and rural, by the way, may not be that much different, pediatric healthcare. And let me just start with this, which is an old friend of mine actually just retired as the CEO of Save the Children. And I was explaining to her what we were working on. She says, well, pneumonia is the #1 killer of kids in Africa. And it's not because there's not low-cost scanner technology. There's just no one to read the scan. And in fact, in Rwanda, there's actually a single pediatric cardiologist, like one, right? And I venture to guess that if you move to the Shetland Islands or to rural California, the number's not that much higher. So we have the potential to take Alberto's brain, Anthony's brain, and put it into computers. But that has a set of challenges with it, of which one of them people have been talking about for quite some time now. This is actually Texas Children's ran a symposium about a year ago, and in essence said, hey, we need data. We don't have enough data. If you understand how these next generation neural networks are being developed, it's basically on the premise that you can feed them tons and tons of data. It's why even to this day, you see cars driving around Palo Alto taking photos and running LiDAR cameras, because increasing amounts of data improve the quality and the accuracy of the AI. So we need lots of data. And if we don't have lots of data, all we end up is with what they will call brittle algorithms, meaning, yeah, they'll work in a certain population group, but as soon as you take it out of that population group, they don't work anymore. So, and just to make a point of it, this is true in adult medicine, but certainly no one children's hospital has enough data to build robust, non-biased AI algorithms. So let's talk about the data, and let's talk about the technology side. We're going to talk about the technical infrastructure, the first challenge. So how do you get these large, diverse data sets to train with? How do you train while preserving privacy? A big question. And finally, okay, I build that pneumonia diagnostic. How do I deploy that AI, that inference engine, to the point of care in Rwanda, in rural California, et cetera? First challenge. Second challenge is, if I have the infrastructure, I need teams. I need teams both of clinicians, who speak artificial intelligence, and I need artificial intelligence people who speak endocrinology. So how do I build those teams? And finally, and we talked about, or I heard this a lot yesterday, the conversation of funding, and I'm going to share with you some innovative thinking, some, as we heard, financial innovation that we've started to work on. So let's start with the technical infrastructure. So what are the technology challenges? Well, the technology challenges, as I said, how do you get to the data? How do you learn with privacy constraints? And how do you deploy? So let me first make a point. The data is not in the EMR. It's not in the EHR. I mean, these are billing systems. That's all they are. You know, the 50 gig of data that the Echo lab at Stanford puts out every day is not going into the EMR. The data is, where is the data? The data is in the machines. It's in the gene sequencers, the blood analyzers, the drug infusion pumps, the ultrasounds, et cetera. And so many of you know, we launched a project about a year and a half ago with the objective of finding a way to deliver precise, secure data sharing from 1 million healthcare machines in all 500 children's hospitals in the world. It is a moonshot mission, but one I think we do have the ability to deliver on, and I'll show you why. We're doing this with a technology we refer to as an edge cloud. Let me give you, I know a lot of you out there are not technical people. Let me give you a brief introduction to what it's about. Much like AWS, GCP, what we call center cloud services, we also here have edge compute and storage services, meaning these computers, and they're fairly powerful computers, are sitting inside Bambino Gesù, inside Children's of Orange County, et cetera. There is compute and storage capability there, number one. Number two, this is designed with a wireless first connection model. So the edge network services are designed with a wireless and 5G first architecture because we wanted to be able to move the servers around, and you'll see why in a little bit. And also with the advent of this new 5G technology, which we have actually experimented with, thanks to Ericsson at Stanford, we can actually use this for way more important reasons than downloading a movie 5 times faster. On that edge server, there are a class of applications we call digital twins. These, in essence, replicate all the data. And by all the data, I mean, what's the serial number? Where's the machine located? What's the last error log? And then, okay, what's the echo? What's the MRI scan? What's the glucose level, et cetera? And just to reinforce it, yesterday you heard, or maybe it was Monday or 2 days ago, the whole conversation about remote medicine, remote health, much of a conversation around glucose monitoring. Hey, you can attach a glucose monitor to the edge server, and all of a sudden you have now access to that data. So the digital twins work for any, and I want to reinforce that, any machine. We have focused a tremendous amount of effort around imaging machines because we see them as the most complex machine out there. The digital twin applications provide data to something we call edge data services. Edge data services are the mechanism for standardization of this data. So once a Philips digital twin application exists, then I don't care where you are in the world, the ultrasound coming out, the error log files, et cetera, are identical in edge data services. Edge data services with permissions, and we have a very fine-grained permissioning mechanism to a single machine, to a single application, you can now share that data. So here I talk about the edge cloud applications, which is the last part of the architecture. So you could develop one, an ISV, and you will see some of this. A system integrator could develop one. Are all running on the edge servers with permissions to the data. So this is all done using something we call Bevel Cloud Studio. We released the alpha version of this at the beginning of August. If you're at all interested in this, send a note to moonshot@bevelcloud.io, and we will potentially give you access to it. We did that because we wanted to bring a group of application developers into the studio. Because, and let me just summarize, we have developed an architecture which has very powerful compute and storage, powerful enough, as you will see, to run federated learning applications based on a wireless first networking infrastructure, completely engineered around security and privacy. One of my former students actually has 14 years of experience in privacy law, and we have engineered a lot of features around security and privacy to allow for very precise standardized data sharing. And I know later on today, you're going to hear some conversation around ethical considerations of data sharing. I want you to think, as you're hearing that, how precise, how safe we can make data sharing to enable many applications to come into existence. So just earlier this week, we ran our first user conference, our first conference. It was obviously virtual this Monday on September the 20th. And I brought some video here to share with you to talk about some of these applications that now run on the Edge Cloud. We presented this. Some of you in the audience might have been there. It was a by invitation only event. We had people from across the world, including Lebanon, Denmark, Italy, the UK, etc. 16 different children's hospitals represented at the event. Our speakers, we had 6 applications running, and I'm going to go through these. 6 applications, 1 Edge Cloud. I'm going to show you 5 of these. So I'll start with Teleray. So Teleray is an application, amusingly enough, founded by the team that built the technology that burns all those CD-ROMs that everybody still passes around. And they built now software in the cloud to do global image exchange. And it's made, the deployment of this is now made much simpler by usage of the Edge Cloud. So I'll let you listen to Tim Kelly, who's their CEO, talk about that application and show it to you.
So I'll show you what our cloud application looks like. For most users, this kind of looks like a PACS in the cloud. Then we add some other elements to it as far as normalizing that data, stripping out those OEM burrs, as we call them, and making sure it can be usable wherever it goes. And that also includes the report data. So whether it's a structured report, whether it's a web report, a text report, that it can be converted or used wherever it's going so we can analyze that data. So I can just click on a study here, open it up. These can be viewed anywhere on any device, completely device agnostic. So whether it's an iPad, Android, Ubuntu, Linux, it doesn't matter.
I'll give you a link at the end of this so that you can hear his whole talk, but a brief introduction to what Teleray has built using our Edge Cloud. Let me take you to another application and kind of go a different direction, because when I said we have all the data in the machine, I'm talking not only about what we call the gnomic data, so the actual, gene sequence or the actual ultrasound image, but also data about the machine, including the audit logs, the error logs, etc. And we actually had the CEO of Umnitsa come. You will be able to hear his entire talk. He actually was just named as one of the top 50 SaaS CEOs. And the Umnitsa application has been built to secure, monitor, and maintain enterprise technology like PCs, laptops, etc. And we have added, with their help, the ability to do this for healthcare machines. I don't need to tell you much about how security is a very big issue across the healthcare community. I think the ability to use Umnitsa to secure these healthcare machines, I think, is groundbreaking. But let me go to the next application, which is more from the clinical side, which I think many of you are thinking about. So I said there were 3 challenges in the technology. One is, how do I get to the data? Well, hopefully you're starting to understand how you get to the data, but how do you train these new AI algorithms with privacy? And I'm going to introduce to you Julia, who's the CEO of Glendor. She has developed the technology. Some of you are aware that in the images, there is often burned into the images the actual PHI. So how can we get rid of that at the edge on the 3rd floor of Lurie's Children's Hospital before I transfer it to a public or private cloud for AI training? So let me let you hear from Julia and show you how this type of sanitization will work.
We're focusing on automatic in situ, meaning in place, reduction of protected health information from medical images. And what do I mean? For example, if we look at the chest X-ray, quite often chest X-rays, DICOM or JPEGs will have information burned into the images at the time of the creation. So in this case, this is just an X-ray, not a DICOM, and not a DICOM X-ray, and it has account number, as well as the date of the study, as well as the name of the person, their age and date of birth. It's pretty small, but it's right there. You also have a lot of information which might be needed downstream by researchers, like the sizes and other dimensions. So what I mean by PHI identification is removing of sensitive information from, in this case, burnt-in pixels, while preserving as much of the relevant information as possible. So in this case, removing the name, the date of the study, and the date of birth, but preserving the chest measurements and other measurements.
Thank you, Julia. As I said, you can hear the longer presentation. I'll give you a link in a little bit, but I think this is really groundbreaking technology that allows us to de-identify, anonymize, right, the data before at the location. You do not now have to trust whether or not Google Cloud or Amazon, et cetera, will be able to do that, or whether it's in the cloud de-identified. You can de-identify it at the edge before it's transferred. I want to show you another independent software vendor. Some of you might not have heard the word ISV. So Dyad Medical is an independent software vendor who's been working in the automated cardiac image analysis and interpretation area. It's actually founded by a gentleman named Ronnie Shalev. And Ronnie, I started out, he got a PhD and started out his career at IBM working on image recognition 25 years ago. Interestingly enough, as many stories are told, he had a son that was born with congenital heart problems, and he's always wanted to go back to solving these type of problems, knowing what he knows now. And so he started up Dyad Medical to really work on this problem. Let me let you hear from Ronnie and see what he's been up to.
It'll be a secure platform that enables anonymization at the edge if required. Right now, we do it on AWS. It would simplify the deployment, since once Dyad is, or Libic is an edge application, it is built, it can retrieve data from any Philips, GE, or Siemens machine, in which case we don't have to deal with this company. It will enable edge compute, which will allow us algorithm and software to run locally, which will solve some of the concerns of the IT department of the hospital. It would enable also deep learning models to be retrained on the fly, which basically says that you are improving over time as you use the system. So our solution is essentially will guide cardiologists in interpretation of the case. It will expand their view so they have greater confidence in their diagnostic. So right now, like Tim said before, we are eager to work with pediatric community on this groundbreaking new technology, and we think it's very beneficial. Right now, we are working with a few local, when I say local, I mean here in Boston, we are located in Boston. We are eager to work with the pediatric community because we think there is a lot of added value in our application for this purpose.
Thanks, Ronnie, CEO of Dyad Medical. Now, you heard Ronnie talk a little bit about running at the edge, running deep learning at the edge. And so I go back to our second question, which was how do we train while preserving privacy? Well, you can actually do learning at the edge. Some of you may have heard of technology referred to as federated learning, which has actually been developed. It's running on your phone right now because Apple doesn't want to take all that voice data and send it up to the Apple cloud and run AI algorithms on it because number one, they're privacy constraints. And number two, it chews up a bunch of network bandwidth. So why do that? And the last point, and I think Ronnie made it as well, there's now the potential to do continuous learning. We sometimes, I think that AI is about, I'm going to take all this data and put it in some giant image data warehouse in the sky, and then I'm going to run my AI algorithms for 3 weeks, and then I'm going to issue this. A very batch-oriented way of thinking, and also thinking about data as being something that just is very scarce. But when you realize that people talking, or by the way, ultrasounds occurring in echo labs around the world are happening all the time, can't federated learning help us rethink how learning happens in a continuous way, which by the way, us humans, we don't think in batch, we do continuous learning. So we have partnered with USC. I'm now branching into the research side of the world. So Salman is a professor at USC. He's actually working on federated learning in Alexa. I will let him talk a little bit about what FedML is, which is an open source project in the federated learning area.
Today, I want to tell you what is it that got us excited together with team on how to bring this technology to the world of healthcare. Okay, so what this animation tries to tell you is, imagine, as Julia mentioned earlier, there are these scarce data and valuable data on, for example, radiation oncology or children's healthcare connected at each hospital. Shared learning across that is key to get better and better models. And the goal here is leveraging federated learning for enabling that. What this animation tries to tell you is you start with models that every hospital is going to locally train. You try to aggregate them across, for example, Bevel Cloud, and then coming up with a better, more representative model and pushing it back to the hospitals. And this keeps going and going. By doing that, you get the privacy because absolutely no data is going to leave. You get collaborative learning, meaning that via collaboration, you get the benefit of sharing the data without not sharing it. And this can go forever. It's not one shot. It's not like every time you have to get permission and doing it. So imagine there is a new type of disease found, there is a new type of anomaly is found. These models are getting better and better. So you get the benefit of privacy, collaboration, and continuation.
Yeah, thanks, Simon. For those tech heads out there, FedML is actually on GitLab, so you could go check out the code base as we speak. Pretty much all of our presenters, as you've already heard, none of us, including me, are clinicians. So I'm going to end with Charitha Reddy, who's going to talk about a project she's launched called EchoNet Peds, which is really coming from the point of view of a pediatric cardiologist. And this is actually, and she's going to show you, well, just so you wonder what an edge server looks like. Well, there's one sitting there, right, connected to that ultrasound. By the way, connected only because we need power to the edge server. So you can now develop these, train, acquire the data, train, and deploy, you see, all the way back to the point of care. So I'm going to let Charitha take you through her project, EchoNet Peds, talk about how it used to be and how it could be in the future.
So enter Edge Cloud and what we've been trying to work on here at Stanford. So back to our kind of workflow. So the image acquisition on the ultrasound machine, we have a Edge server that's physically on one of our ultrasound machines here at Packard. The idea, and we can run the EchoNet Peds algorithm on the Edge server. And as of right now, it would just be kind of a web-based automated ejection fraction result. And so already this is kind of an exciting use of the technology to be able to kind of add this on and end up with a result with the ejection fraction prediction. And the ways that we envision that this could improve workflow is that instead of making some of these adjustments to measurements later, or to think that, oh, this image isn't accurate and that's why it's giving us a wrong measurement, we have the ability to kind of use this potentially to real time make those adjustments and reacquire images if necessary and minimize the missed diagnosis aspect of it. So our ongoing work is to kind of still have those first two steps be the same, or first three steps be the same, and then potentially figure out more clinically relevant ways to incorporate things into the workflow. For example, a verbal notification of an abnormal ejection fraction. So then it would notify the user to go down a different path to change their algorithm and assess for any sort of clinical differences. So Salman had beautiful images of federated learning. This is my PowerPoint, just Windows Paint kind of version. But essentially, the idea is exactly what he talked about. We are very interested in kind of moving something like EchoNet Peds into a federated model, such that we worry less about pediatric institutions sacrificing their privacy for their fragile patients, and so maintain that data locally and allow for the algorithm to be dynamically improved. One of the challenges that we've seen in the academic world is that once a algorithm is designed and tested in a local institution, it's much harder to then deploy that and test it on a demographically accurate population. Are we capturing every type of patient that exists when we're just doing it at one institution? And the answer has been shown to be no, but we haven't figured out an elegant way to do that. And I think we've been able to see that in some of the presentations here.
So yeah, thanks to Charitha, and I like to say the story that started at Stanford, and we've kind of come full circle here to talk about a very advanced application that Charitha and her team are starting to work on. I just want to conclude this technology section by saying I just showed you 6 applications running on one edge cloud. We are headed to, and you'll see this in a minute, running this in 8 zones at the 8 Vanguard hospitals before the end of the year. So being software people, this is like, let's build and go. We're like, want to advance the state of the art as fast as we can. These are all imaging related applications with the exception of IMNITSA, but hopefully I got you understanding that building digital twin applications can bring this to any machine out there. So I said you can hear the full presentations at this link, and I think they'll share this in another way later. But this contains the full 90 minutes. Each presentation was about 12 to 15 minutes, and you just saw snippets from it. So if you're interested in learning more or sharing this with other people, what we call the TV show is now available with 7 episodes. So what's my call to action? What am I asking you guys for? Where do I want you to think about? Well, I titled this AI4Kids, 1 down, 2 to go. When I say 1 down, I think we figured out how the technology infrastructure works here. And you've already heard me say this. We have been very interested in moving this into the real world. We launched the Vanguard program a couple of months ago that is limited to 8 hospitals because we're covering all the cost of doing this, of actually deploying an edge cloud in these 8 hospitals. 6 of these slots are taken. We have 2 that are still open, and very eager to talk to anybody who's interested in participating so that you can see firsthand what we're talking about here. We literally are trying to get out of PowerPoint into software as fast as we can. So technology, I'm going to say check. We are well on our way to answering the technology questions. The second question, the second challenge is, hey, that's great infrastructure and lots of software, but how do we use this to build AI algorithms for any number of different conditions in cardiology or endocrinology or neonatology? I'm starting to learn all these words. And so I think there's a challenge here of getting people educated and both sides educated, both the clinical community, and I'm putting a challenge out there that in all 500 children's hospitals, this does not have to be the domain of a Stanford University or the domain of a, Children's of Orange County. This could be everybody. So a challenge to get all of you guys to learn the language of AI. I'm not asking you to become programmers. I'm asking you to understand the concepts here. And I'll, give a shout out again to Anthony. He just released this book, Intelligence-Based Medicine. The AI medicine program that he runs are many different ways in which to get educated. So as clinicians get educated, to the AI community, many of them are already very interested in the challenges that we have here. I will challenge you that you as clinicians are going to have to explain to us, I like to say the difference between a left ventricle and a right ventricle, which yes, I know they're on the left and right side, but we don't understand enough about your world. So we need to learn each other's languages. That's a big question and a big challenge. And finally, all this is really cool, but if there's no time to work on this, and I have worked with a number of you guys, and I can tell, you can give me time at 7 o'clock at night after you're off your rotation or your weekends, etc. How are we going to fund this? How are we going to give the time to our clinicians? How are we going to be able to bring the AI experts into this? Well, I really appreciate John Parker's evangelizing that the venture community should see this as an opportunity, but it is evangelization. So it's not going to be easy. John, keep preaching is what I already said to him. We went in and looked at the NIH budget, and in a $2 billion spend on healthcare and kids, there's nothing on AI. And so I think there's an enormous challenge of how do we fund this? And I think yesterday, the session Alberto was running, they talked about the need for financial innovation. And I'm going to tell you a little bit about a project that we have started to bring together, public and private, to really think about how do we kickstart AI development on a planet-wide basis. And this program we're calling AI4Kids. I'm glad to go into it deeper with any of you, but it's in essence what we think of as a focus around how to bring, and I'm going to throw a number out at you, $50 million to this problem to kickstart this on a global basis. So AI4Kids is, I'm going to call it financial innovation. I'm going to conclude my remarks by saying we know it was a moonshot mission, this mission to enable data sharing from 1 million healthcare machines in all 500 children's hospitals. I think with the sponsorship of many of you here and this community, this is becoming much more of a reality than I think a lot of people thought was possible. If you're at all interested in learning more, I've got a bunch of contact information. I'm on LinkedIn. I publish stuff into Medium if you're interested to learn more about this. But I just want to leave with one thing for you to think about, is that we have now separated the question of where is the data, where is the AI expert, and where is the clinical expert. So now I could have a clinical expert in Italy collaborating with an AI expert in Southern California on data that's coming from 8 different hospitals around the world. So it helps you rethink how innovation could occur here at much faster rates than we've ever seen before. So I'll end by asking you who have not joined us on this mission to do so, to become part of this. Reach out. We do weekly newsletters. We can show you what we're working on, et cetera. So join us on this mission. I'll end my comments, and Alberto and I have left 5 minutes for questions. by telling you that I'd love to stay for the rest of this, but I'm actually going fly fishing on the Yellowstone River right after this talk is over, and that's a photo of my brother. Well, maybe not my brother, but thank you all for listening to this, and for all of you who have been a part of our moonshot mission, and I invite the rest of you to join us. So Alberto, what should we talk about?
Thank you so much, Tim. This was amazing. Also because so many things that we have been discussing during our talks come clear when you actually put them one after another. And I hope that this will be motivating also the hospitals that are not considering to join the program yet. You know, one of the keywords in your project is collaboration. And one of the things that we are frustrated about is sometimes hospitals just compete with each other for being the best one or for delivering the best services. This is one absolute reason for collaborating together and bringing more value to the quality of care that we offer our children. This is the most important and single objective that we want to achieve. One of the things that I might leave for one of the final comments, you know, you touched about the location of the data. Electronic health records are not the place where to dig or to extract the data. But at the end of the day, actually, you should link all these things to the electronic health record. How do you envision the integration of this stuff into the electronic health record, which is currently the only tool that physicians use when trying to do the best, to apply the best evidence to their children?
Yeah, well, you know, part of me, let me just make a point. Part of me, I'm so like negative on EHR, EMR, because the technology this stuff was developed on was like, you know, developed 20 and 30 years ago. And being in the software business, I mean, innovation with code bases that are that ancient are really hard to do. But to answer your question, you know, these are computer programs. This is software running at the edge, as we just described, and running at the center cloud. I mean, what you saw, Dyad Medical, et cetera, is part of that application is running in Azure in their world. So an application that you wanted to develop at Bambino Gesù, you could not only acquire the data from all the machines in the world, but you could also get the data from the EHR using whatever connectors, et cetera, that they have developed to allow you to do that. But as I said, I'm actually hoping that this leads to a renaissance in how we think about the entire healthcare process. In fact, I was talking to folks at Intermountain Healthcare, which some of you know in the adult medicine world, about we should think about architecting the future of healthcare around the machine data, not around the billing system. And they so agreed with us rethinking this. So anyway.
That's amazing again. And thank you so much, Tim, because every time we discuss together, I discover something more, which is good because, you know, as a poor clinician, sometimes I don't have everything on the table to understand what are the single steps of the process. And I think this is also extremely important for the future generations of clinicians to understand how powerful can be the application of AI. It's not something abstract. Okay, yeah. Thank you so much, and hope to meet you again. Have a good time fly fishing. I'm a little bit envy, and thanks again.